I'm not.
It's the exact type of paint with aluminium in it. So what? But you don't seem to understand why they use it. It's used for. I explain. I mean, it's used for. It is used for its to stop corrosion. It's meant to. It's prime a barrier to stop water getting into iron steel. Though. That's why it is. I thought you might have known things. You might have looked at alternatives, but you don't.
We're looking for the primer paint.
It's fine. It's fine. Okay, you don't.
Hey.
Okay.
We have looked at the primer paint applied in wood.
You've looked at one primer paint.
We have looked at the NIST report, which made an account for the primer paint.
Right.
Okay.
You looked at
That's one thing.
Yeah.
And we have obtained authentic samples of the primer paint from the steel beams, and they perfectly, fit the description in the NIST report, and that is the basis of our conclusions, of course.
And Professor Christopher Pistorius states very clearly that in an area like the World Trade Center, there would have been a whole series of different primer paints used, not just one.
So why is it not in the NIST report, and why doesn't he come up with it?
Well, he did come up to it, and he did explain it to me. If you heat a cured paint with polymer iron oxide aluminium, like the one we're talking about, heat will be released, yes? The polymer will burn, the aluminium will react with the iron oxide, and the heat released by it, according to your paper, is around about 1.5 to 7.5 kilojoules per gram. That's the scientific calculation for it. How does that amount, what does that compare to a typical office fire? What do you think is the amount of heat being released by that in the same?
I have no
Don't you?
idea. After the burning of coal, actually.
No, just take an office fire. Quite important to say, because you're saying it's got some special characteristics, this.
Yeah, but the point here is not...
Now that's the question. How much, in comparison to an office fire, is being released in terms of energy? The same calculation.
I don't know, actually, but I probably you'll get more out of the office fire, because when coal burns...
Yes, it's twice as much as the most... So it's 15 kilojoules per gram.
Yeah.
That's twice as much as from your supposedly dangerous compound.
No, you haven't understood.
I've understood perfectly. And there's more energy being released out of an office fire than there is out of this supposedly highly dangerous material.
I have to then entertain you a little bit about basic chemistry. Because what you are referring to is the combustion of carbon, basically, furniture, trees, wood, okay, in air. So there are two components in that reaction, and that is the carbon in the wood and the air. And it is a very slow reaction. It's true that more energy is released, but it's very slow. So over the time, probably, actually, it's true, more energy is comparable, twice as much is comparable. It is more energy is released when you burn carbon, but it's what we call a diffuse fire. It's burning from the surface. So you can never reach temperatures of 1538 degrees centigrade, which is the melting point of iron. Do you have a stove? Have you ever seen a stove? Have you ever seen it melt when you put in wood in the stove? Have you ever seen that? No, of course not. You cannot melt iron in ordinary office fire. You are at least, eventually, 1,000 degrees below the melting point of iron. So come on. You are referring apples and oranges.
It's an inconvenient fact for you. It produces more. I mean, in fact, NIST actually says that the office substation they looked at produces 17 to 20 kilojoules per gram.
Yeah, but you would
that's nearly 3 times as much as energy is being released by your supposedly highly energetic material.
Time is an issue, and the point is the temperature you reach within time. The thermite reaction brings its own reactants, and it reacts very fast. So that's why you get a temperature of 2,500 degrees centigrade. Now, in office fire, unless you blow in oxygen, you don't get beyond, say, 700 degrees centigrade. You are roughly 800 to 900 degrees below the melting point of iron. So your point is irrelevant.
It's their point.
Your point is irrelevant. Yeah, but there are many irrelevant points in the NIST report.
Well, they don't think it is. They're experts in metallurgy, world experts in metallurgy. They don't think it is irrelevant. But I guess you'll dismiss them
Trust yourself.
because they say something contrary to you. The temperature at which it started to react was what when these red grey chips? What
430.
Right.
Yeah.
Okay.
Yeah.
And what would you expect it if it was thermite?
Oh, actually, there's no. It's very hard to find ignition temperatures on thermite.
But it wouldn't be that, would it? It wouldn't be 430.
No, as a conventional thermite it can be ignited old time. Hans Goldschmidt, old time thermite, can be ignited by various means, and it's very difficult to find well-defined ignition temperatures.
But it wouldn't be 430, would it?
Definitely not. It's much higher.
Right.
But the point here is, what I believe, and we also said that the polymer matrix helps along for the relatively low, and actually it's burning. So it helps along to the low ignition temperature. But it's characteristic for nanothermite. Yeah. It has been produced. We have made nanothermite ourselves independently, following the recipes from the Lawrence Livermore National Laboratory. And it takes off at these low temperatures.
And guess what? If you burn the paint that they're talking about, the primer paint they look at, it would burn out exactly around about 430 to 450 degrees centigrade.
No.
Well, Professor Christopher Pistorius from Carnegie Mellon says it would.
Yeah, but I have made experiments with primer paint from the towers.
You've made experiments on one?
As a few, but I have made experiments on authentic primer paint from the towers. I've heated it up, and I promise you, nothing happens until 800 degrees, and what you have left is black tar. Combustion.
Okay. So, there you have two of the world's leading experts in metallurgy produce A, questioning methods you've used, and B, suggesting a completely harmless but much more plausible and more likely reason for the red grey chips and the characteristics within them. Why don't you accept what they say?
Because I want to read them face to face, and I want them to publish this. I don't take your report for you as go in between here. Maybe you made this up on your way down here.
I made it up?
Yeah, it could be. How do I know? I want to meet them. I want them to publish and come out in the public domain and say what they're saying. Provide their evidence. Why don't they provide their evidence? I'm talking about evidence all the time.
But they've done an interview with me. Do you think that I made that up? Or?
No.
But you seem to suggest they...
No, I'm just saying that I'm, of course, ready. Why don't they invite me or any of the other authors to their university and let us, each of us, give a presentation?
Because they say it's irrelevant. They say it's not worth further study. They wouldn't have published your paper in their journal. They don't think it's of the right standard. That's why.
It's a very personal thing, isn't it?
Well, it's not. It's a question. You're a scientist. You're saying it's got the right standard. They say it hasn't got the right standard.
Okay.
If he peer reviewed it, he would have rejected it. He said Professor Fruhan.
Okay.
Well, that's pretty serious, isn't it?
No, it is not.
A professor of 50 years' experience in metallurgy, one of the world's leading experts in exactly this field. It's not your field, is it? Your field is not metallurgy.
I'm in nanoscience, but it is true.
But your field is not metallurgy, is it?
Why doesn't your professor...
Is it your field metallurgy?
No.
He is. He's got 50 years' experience, but yet again, you say that either I made it up, or that for some other reason, you would suggest you don't want to listen to a leading expert in the field.
Of course. Of course I will.
This is absurd.
Where is he? I'm not listening to him.
I just quoted exact quotes of what he said.
Very good. So let him come out in the public domain.
The standard's never quite good enough for you, is it? When someone has something that's contradictory, it's never quite good enough for you, is it?
But he hasn't presented himself to me. You're a go-between between him and I. Okay? Him and me. Okay? So I suggest that your professor publish and defend his statement in the public domain? Why is
Well, he has put it in the public domain. He's just done an interview with BBC, hasn't he?
Why is he
pretty clearly in the public domain, isn't it?
Why is he hiding?
I don't think he's hiding anything.
And he's saying that it is not worth written. But
He wouldn't have published it. He just said, you know, I asked him a question, would you have published it in your journal? He said, no, I wouldn't. If I peer reviewed it, I would have rejected it.
okay,
Because it wasn't up to the correct standards of science. It's not how we do that sort of research now. It might have been 30 years ago. It isn't now. And he disagrees with your conclusion. He said you were being selective.
well, why? I still suggest that he come up with his criticism following the standard rituals, routes for doing that, instead of actually giving it an interview, as you claim, with BBC again.
So you suggested I claim
No,
as
I'm
an
not.
interview or what?
Please, let me repeat.
Well, that's
What-
why you've decided to record the interview. I mean, you're saying things that I don't accept. I don't claim there's an interview. There was an interview. There was an interview, and I've given you exact quotes of what someone said.
And
yet again, you're not willing to accept what someone said.
I haven't taken a position on that.
Right. Okay.
I'm saying that what is needed here is a public hearing among peers. Because when you take in any single individual, and that goes for me too, in an interview, you can get any opinion you want out there. This has happened, it's true. This is something which has happened to academia, and I can explain to you why, because it's based on the funding system and the whole thing.
They'd never heard of your paper. I asked them a question about it, they answered. I don't think it's any more complicated than that. They gave you an answer you didn't like, so you dismiss it.
What is needed?
Pretty simple to me.
No.
You don't like things that seem to contradict your point of view.
No, I'm saying let's take the decision into a forum of peers where we can discuss things, and where somebody are presenting their opinion, because you have to bring people together in order to have a proper scientific discussion. We should not discuss with any relays. That's what I'm saying. What I'm calling for is a scientific symposium on 9/11 science, and this could be an issue. And I'm suggesting your professor to invite me or Professor Jones or Kevin Ryan or either one of us, preferably together, at a symposium at his institute, and let's talk it over together with his colleagues.
I know a person who's from a completely different end of the spectrum, who's helped found Scholars for 9/11 Truth. Professor James Fetzer says that he suggests that nanothermite only becomes explosive if it's combined with explosives, which is true. It's an incendiary. And the same is true of toothpaste. If you combine toothpaste with an explosive, then it becomes an explosive. The inherent characteristic of thermite is an incendiary, not an explosive.
We don't know. We don't know. We don't know where the red grade chips fit into the demolition picture of the World Trade Center. We know that incendiaries were used, and I can come up with a list of 10 other observations, which each of them unambitiously imply the application of thermite.
So how could someone have got into the World Trade Center and planted a...
Let me finish.
It's fairly important.
Let me finish.
Okay, we'll answer that question next.
And we can bring to that access
Okay.
to the tower things afterwards. So, we know that incendiaries were used. They must, by necessity, have been thermitic. We also know that explosives were used simply from the cause of collapse. They could have been thermitic, because modern explosives are based on these very same reactions. It's called composite materials. They are based on these reactions. But we do not know where the red grade chips fit in. They could, probably more than one kind of thermite was applied. But then we have to talk about sulfidation of the steel. But so we do not know where the red grade chips fit in. The only thing we know is that they shouldn't be there, and it is thermitic material because iron is being formed in the process.
Have you done any calculations on the size of the building and working out the size of the steel and how much thermite you would have needed to bring down that building?
A lot. No, because
It's quite a lot, isn't it, actually?
Yeah, tons.
Tons.
Yeah.
And no one saw anything untoward in Building 7, no pre-cutting, no storing of tons of thermite, highly reactive, as you say.
How do you know?
Because I've not found anyone. Have you found anyone who said anything? Saw sort of someone carrying tons of thermite into the building, placing them by girders, ripping off fireproofing, placing them in all the key positions that you would in a controlled demolition?
Again,
have you found anyone?
Well, if you found anyone, would you report it in the BBC?
I certainly would.
Okay, but I think.
Have you found anyone?
No. But I can tell you that the access to the towers has been very well documented by Kevin Ryan. This is one of the co-authors of this paper, and I would suggest that you read some of his essays on the way he is very. It is not difficult to get into the towers, and the key thing here is to get access to the steel structure.
But you're talking about taking in tons, as you accept, tons
on
of thermite.
pallets. On pallets. No, and explosives. I don't.
And explosives all over. Rigging the place with explosives, wiring.
Yes.
And no one saw it.
Why do you know?
Really, it's just absurd, isn't it?
How you know? What you know is that nobody reported it. Okay, that's a different thing. Because of course somebody saw it. But you don't have to, if you have a pallet with explosives and you're bringing them into World Trade Center, you do not write on the side explosives for demolition, would you? You would just bring them in.
Professor Fetzer also suggests that the nanothermite has been